Good afternoon, students. So, today we are going to study chapter 1 periodic table, periodic properties, and variations of the properties. Which is the first chapter of the class 10th ICSC board. Okay, so let's start with the introduction. Now, actually, as we are studying about the introduction is the periodic table. So what first of all we should know that what is periodic table is made up of. Means we know that periodic table is made up of elements. Okay, so as the periodic table is made of elements, so what are elements? Okay, so what are elements? That are elements are the pure substances made up of one type of atoms. Okay, elements are pure substances which are made up of one type of atoms, or we can say same type of atoms. Okay, so what we get to know here, it is that uh, elements are the pure substances which are made up of same type of atoms. You have to underline in your book what I am underlining here, because it is very helpful to you. Now if we check the next here, then we are able to know there are three scientists. Okay, Dobronier, Newland, and Dmitry Mendeleev. These three scientists are, see, the first is Dobronier triads. Okay, what? First is Dobronier triads. Dobronier triads. He composed a law that he couldn't. Okay, means he could prove that if three elements are taken in a period, then then the first element and the third element average atomic mass is equal to the second atomic mass or second element atomic mass. Okay, so he could prove that, but it failed. Why it failed? It had some reasons of failures also. Why it failed? Because it could not work in same period also. Okay, this law could not work in same period also, and this also failed. Okay, now next came the law of Newland octaves. Okay, this law suggests that, and first of all, this Newland means this scientist was lover of music. So what he did, that he arranged these means arranged the letters in the form of the what in the form of sa re ga ma pa dha ni sa in the tune. Okay, tune form. Okay, as he arranged in the tune form, so he formed a periodic table in that manner. Okay, but this also failed, as because this it was the elements also not the the law that that the scientists gave, that the every eighth element beginning from any element resembles the first element in the physical and chemical properties. That okay, so what every this law failed. Okay, this law failed. Now third scientist came the Dmitry Mendeleev. Okay, only the 83 elements were known at that time. At the so he formed a table with this formed a periodic table with only 83 elements, and he gave some elements name like Eka, boron, and all. Okay, then okay, now what happened, that he also gave a periodic law. What it states, that the properties of elements are the periodic functions of the atomic masses. Okay, this was suggested by the Dmitry Mendeleev. That is the periodic table of that is a scientist law. But after that, Henry Moseley uh, the scientist name, it is a scientist name, gave another law that the physical and chemical properties of elements are the periodic functions of their atomic masses. Okay, by this we are known that just we have to change here. Here it is atomic mass, and here it is atomic number. But what happened that then this scientist formed a periodic table, whole periodic table. Modern means, and just he gave this scientist Henry Moseley only gave modern periodic law. Okay, now then the periodic table was formed, and the periodic table is formed by vertical their columns, they are known as groups, and horizontal rows which are known as periods. Okay, now this formed the periodic table. Okay, now what's new in this that as they all form in the periodic table. Okay, as they have formed this new means modern periodic table, so there were seven rows. Okay, not seven rows, seven periods we can say in the language of periodic table. Seven periods were there and 18 groups were there. So what are groups? See, now only I have told you that groups are the vertical columns, means the we can say like standing columns, and periods are the horizontal rows. There are seven periods and 18 18 groups are there. Okay, now next is, okay, next we are next on next page there is a modern periodic table. Okay, it is a modern periodic table, and let me explain this whole periodic table. See, here there are seven periods, as I said, so 5, 6 and 7. There are seven periods and there are 18 groups. Okay, 18 groups. These are the standing line is called means standing means we can say vertical. Vertical columns are called as groups and these are called periods. As mentioned here, see, these are groups and these are periods. Okay. Now, next we are known that, see, the first group is known as alkali metals. Okay, the first group is known as alkali metals. The second group is known as alkaline earth metals. Okay, okay. The next is 13th group is known as boron family. This 14th group is known as the carbon family. This 15th group is known as nitrogen family. This 16th group is known as oxygen family. They are also known as chalcogens. And the 17th group is called halogens. And 18th are called, and 18th group is called noble gases. Noble gases means which can't react with anybody, which can't not but which are stable and are not reacting with any means anybody, any element, as you can say. Now this is the S block element, D block element, P block element, and the just you can see here downside that there are F block element here. See. They are the called lanthanide series and acetonide series, which are called lanthanide and acetonide series. Okay, so we are as I said, what I said here, it is given here. See, these are called alkali metals and group 1. Then they are, say, group 2 is called alkali earth metals, alkaline earth metals. Then they are called transition elements. This group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are called transition elements, and the lanthanide and acetonide series are called inner transition elements. Then 13th group is called boron family. Then 14th group is called carbon family, 15th group is called nitrogen family, 16th group is called oxygen family as well as chalcogens, and 17th group is called halogen, and halogen means salt former. And 18 group are called zero group or the noble gases or inert gases. Okay, as see here, note are also given. Note is very important. You should star mark the note. Okay, it is very important. See what it is saying, that the 1, 2, 3, 13, 14, 15, 16 are known as main group elements or the representative elements or normal elements. It means that the alkali metals, alkaline earth metals, then boron family, carbon family, nitrogen family, oxygen family, and halogens and the noble gases. Okay, not noble gases, only just till halogens. Okay, they are known as main group element or representative or normal elements, as we mainly study these elements only. Okay, we do not study mainly the inner transition elements or transition elements. So next are periods. Now, as I said that there are seven horizontal rows. Okay, there are seven horizontal rows which are known as periods. Okay, these are horizontal rows are periods. Okay, and I want to say one very important thing, that here in your textbook, that it is given that here, that number of shells means, see, if we take potassium. Okay, if we take, wait, let me change the color. If we take potassium, okay, if we take K means potassium. K atomic number is 19. Okay, K atomic number is 19. So what is the electronic configuration? 2, 8, and 9. Okay, so how many cells are there? 1, 2, 3. Okay, sorry, 2, not 2, 8, 9. It is 2, 2, 8, 8, 1. Okay, sorry for this. See, here it is 19. So 2, 8, 8, 1. I forgot about the octet rule. Sorry for my mistake. Now see 2881. So how many periods are there? I mean, how many cells are there? 1, 2, 3, and 4. Okay. So it belongs to fourth period. And how many valence electrons are there? 1. Okay. So it belongs to first group. Okay. So by this you can check the group of any element, or period. Okay, period of any element. By this you can check the this method is true. But just you have to take care you are seeing when you are seeing wait when you are seeing uh, when you are seeing the this boron family, carbon family, nitrogen family, and oxygen and fluorine family. Why? Because in the, see, if we take fluorine example, let me take an example as fluorine. Fluorine is 9. Okay, as you are able to see here, fluorine is 9. So we will get 2, and we will get sorry, K shell will take 2. So 2 and 7. What we will get? 2 and 7. So see here, 7, if we take check about the valence electron, then it is 7, but it does not belong to seventh period. Okay, so we have to add it plus 10 to it. Okay, so 7 plus 10 equals to 17. So we will get the period, sorry, group number. So if we check about, if you have to just take care in the boron carbon family. Okay, boron carbon nitrogen oxygen fluorine family, otherwise you are able to uh, do it. Okay, but it doesn't works in the, you can check first alkali, the alkali and alkaline earth metals. It does not work in these two groups. common chain. Now, next if we see, and this is a note, it is very important. Okay, note down what they are telling, that lanthanides group 3 of 6th period and acetonide group 3 of 7th period have similar properties because they belong to same group 3. Okay, are you able to get it the point? Okay, see, lanthanides group 3 of 6th period and group 3 of 7th period and acetonides group 3 of 7th period have similar properties because they belong to same group 3. So why do have they similar properties? Because they already belong to group 3. Okay, are you able to as see, let me show you, let me I show you the periodic table again. See, where our lanthanide series is here, acetonide series is here. Okay, are you able to check and which group it belongs to? Third. As they are in same group, they are having similar properties. Okay, now if we check, then next topic is periodicity. Okay, next topic is periodicity. Now, what is periodicity? That the properties which reappear at the regular intervals or in which there is a gradual variation or increase or decrease, means what they are able to uh, what they are able to tell, that the properties that there are similar properties which are reappear at regular interval of elements are called periodicity. And what is the cause of periodicity? That because they have same electronic configuration, as you are able to see here. It's recurrence of similar electronic configuration. That's why they have say a period. I mean periodicity is the cause. Now see, this is an example given. You can check it by your own because it is easy to understand. Now, if we check about the cells, orbits, and valency, we are able to know that C or cells, orbits, and valency. Now, orbits. What are orbits? The electrons which revolve around the fixed path which electrons revolve around the nucleus is called orbits. Okay, orbits. This definition is important. It does not ask in question, but you have to know it. Now, if we check next, then number of shells. Number of shells. If we check next, it is the topic. What is a trend in it? Okay, trend we have to see. Okay, see now. It is very important. These trends are very important, and you have to understand it with logic. Just be with me in video. I will tell you the whole logic, how you can understand it, and how you can just we don't have to remember the trend. We have to understand by it by logic. Okay. Now see, number of cells. They are telling that how is the property it is. Okay. Down a group it will increase or decrease. Number of cells will increase or decrease. See, here example is also given, that fluorine. Fluorine is 9. Okay. So what is the electronic configuration of fluorine? 2 and 7. Okay. So down a group from top to bottom. See how they are having 2 8 2 7 fluorine 9. Okay, it is 9. So fluorine is 2 and 7. Okay, are you able to get my point? So 2 7 is there. So it will belong to second period, as I told you. See, periods are increasing one by one, but groups will remain same. Now see, chlorine 287, bromine 28887, iodine 28887, SC one group plus as one group is no sorry one period, as the period is increasing, the number of cells are also increasing. Are you able to notice what I told you before? As I told you that number of cells is equals to number of period. So number of period is equals to number of cells. So see what the period is second, the how many cells are there? 2. Period is third, the how many cells are there? 287. So periods are 4, how many cells are there? 2, 1, 2, 3, 4. 15, fifth, 1, 2, 3, 4, 5. 6, so 1, 2, 3, 4, 5, 6. If 7, then 1, 2, 3, 4, 5, 7. 5, 6, 7 means. This is the logic in this. Now, if we check on moving across the period, then we are able to notice from left to right the size. See, the cells number of cells remain same. Why? Because the as we see, as we check through the same period, so will the cells increase? Okay, if we are checking through the same period, okay. So if we are checking the second period, so same cells will have, because we are only checking in the second period, not we are going in the third period. Okay, so it will remain same. Now, if we check about the valency, then we are able to notice that valency denotes the combining capacity of element, as we are studying from was understanding that valency is the combining capacity of an element, as it is okay, combining capacity of an element. Now, next. Next, they're telling that this note is very important. I am also explaining you. Note 1 says that valency depends on a number of electron in the outermost shell. Yes, as I told, see, where fluorine, if we example we take, okay, fluorine is 9, okay, fluorine atomic number is 9, so 2 and 7. What it is telling that, okay, see, valence depends on the number of electrons in the outermost shell. Yes. How much it will gain and how much it will lose. Okay. If it will, if more than 4 is there, okay, more than 4, it will form anion. Okay. As it will gain 1 electron and take a charge -1. Okay. Are you able to notice? Same if we take an example of Na. Na atomic number is 11. Na atomic number is 11. So how much? 2, 8 and 1. See how much it will donate? 1 it will donate. So it will carry a +1 charge. Okay, are you able to notice my understand my point? It will carry 1 charge, +1 charge means. And see here, you can are able to check how to calculate it. This, but I have showed you the same path to do it. See, check 8 minus 7 equals to 1 respectively, as I showed you now. And as it is a combining capacity, so it is always positive. Okay, now you will tell that, sir, that valency is a combining capacity, we understand, but first you told that fluorine is having -1 charge and Na is having +1 charge. Okay, +1 charge. Okay. Okay, then you are telling that this is also valency and it is a minus, and here you are telling that it is always positive. But we don't have to count this charge. This count we are counting this charge when uh, because see here electron is okay. Here if you understand like this, then you will able to understand that, see here if one electron is gained, okay, so the negative charge will be increased. So but that's why we put here minus. And if we check in this, then one electron is donated, so their protons are more, so the positive charge increases. Valence, we have to see valency is this 1, okay, not the +1. Are you getting my point? Okay, this is also important. You can read by your own, or I will explain now. In the periodic table, elements are arranged in order of increasing atomic number. Yes, as I said, that elements are arranged in the order of increasing atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Vertical columns are called groups, and horizontal rows are called periods. Okay, next. You have to solve these syntax questions by your own, or you can check the solution on my channel. Okay, now this periodic properties is very important. Okay, periodic property is very important. You have to understand it, not mug up. Okay, now atomic size. First periodic property is atomic size. These are the given name of the periodic properties. You can check here. This atomic size, then metallic character, then non-metallic character, ionization potential, electronic infinity, then electronic affinity, electron negativity. Like that, they are given the name. Now, atomic size, if we check, then this is the atomic. It is also known as atomic radius. What is the atomic radius and what is the atomic size? Both are the same only, but the distance between the last orbit and the nucleus is called atomic radius or atomic size. Next is next they have given that if it is a covalent bond. Okay, if it is a covalent bond, see here it is a covalent bond. You are able to see here that it is a covalent bond. So what we have to do, that we have to, if we have to check the radius, then we have to check the distance between this both nucleus. Okay, then we are able to get the distance. Next is number of cells. Now as we move from top to bottom, then we will get here the number of shells. Okay, number of shells. And an increase in number of shells increases the size of atom. Okay, you can check here also, they are given, but I will explain you this in a whiteboard so you are able to understand properly. Now just check here how I am explaining. See here, first if we check here that we have to check, there are 5 or 6 periodic properties. First is the atomic size or atomic radius. If we check down the group, then it will increase. Why? Let me show you. Na plus, okay, Na plus, if we check, okay, Na plus, Na plus, not Na, Na11 is there. Then see, Na plus Na11. So what is the configuration? 2 8, 2 8 and 1. Okay, and correct, miss K is 19. So what is the electron configuration? 2 8 8 and 1. 2881. If we check here, okay, so 2881. Okay, we are able to tell here. So as we go, as we go down, we are able to see that the cells are increasing. Here see 1 2 3, here 1 2 3, cells are increasing by +1. See here are 3 and here are 4. Okay, by +1 there, the cells are increasing. So obviously the, we can say, the atomic size will increasing as the cells are increasing. Okay, and if we check down the group, okay, if we check the down the group, then we are able to notice that if we check down, down, not down the group, the across the period, then we are able to notice that the size remains same. Why? See, let me check off the second period. Lithium is 3, and boron is 5. See, check here, 2 and 1. Here is 2 and 3. See, the cells remain same. Why? Because the period is same. This is the element of second period, so the cells will remain same. As cells remain same, so we are able to see, so the size will decrease. Why? It is a major reason that you will tell that as the what we can say, as the cells are same, the why the size will decrease. let me explain you that we check that protons are here more, okay, as protons are here less in Li, the protons are less here than boron, okay. That's why the nuclear charge will be more, and so the if the nuclear charge is more in boron, then so the as we go across the period, the size will decrease as it is given here. You can check here that see down a group, down a group here, down a group in a group, the size of atom increases as one proceeds from top to bottom, and this the proof is with proof. It is given here. Okay, you can check the near the table below. Check here that hydrogen and hydrogen, lithium, sodium, potassium, rubidium, cesium are given here. Now what they are known, see, check here, you are able to see here, see atomic radius, as we go down it increases that 37 picometer, 152 picometer, 186 picometer, 231 picometer, 244 picometer, 262. As the number of cells increases, the size also will increase, okay. This is important to learn. I am explaining by logic, so don't mug up, please. Now, across the period, as I said, that it will increase. Sorry, it will decrease. See, it is decreasing. That 152 picometer, 112 picometer, 88 picometer, 77 picometer, 70 picometer, 66 picometer, 64 picometer, and you are able to see the change. Okay, as a new you have to write that if someone asks that why it is decreases, okay, across the period, then you have to say as the nuclear charge also increases and the cells are same in a period, so the nuclear charge will increase, and the size of the what I can say, the element will decrease. Now this is very important. This note is very important, okay. This note is very important, and this topic is very important. This third topic, size of isoelectronic ions, we have to say it isoelectronic species, okay. I will explain this topic in a whiteboard. So see, if we talk about the cation, what is cation? Positive charge ion. So if is a there is element L named X, okay, then if it is having positive charge, then it is a cation. If it is having a negative charge, then it is known as a anion, okay. Are you able to got me? But it as it is return cation, so it is positive charge, okay. Now if let me take the positive charge, okay, let me take an example of sorry for my, let me take a charge of sorry example of Na is 11, so 281 281, so as we take here 281, okay, so as there are having three cells, okay, three cells, so the size will be same. Now it will now donate one electron, so what it will become, Na plus, okay. So what is the it will become Na plus, okay. What is the configuration now? The configuration is that uh, the configuration is that here that now see what is the Na plus configuration here, that 2 and 8, okay. So the cells will number will decrease. As the cells number will decrease, then as cells number will decrease, so the size will also decrease. So cation size is always small than the parent ion, which is shown here. Check here. Check that the cation is always smaller than the parent atom. You have to underline in the your book that which I am highlighting with yellow. Okay, it is important. See, reason I explained you here. And now I will explain the second one here. That see now second one is that here that second one we if we say second one is about anion. Okay, anion says that anion is if any element is X and donates one gains one electron, then we will having a negative charge. If we talk about the chlorine is 17, atomic number is 17. What is the the electron configuration? 2, 8 and 2, 8 and 7. So it will donate gain one electron. So what is then after gaining one electron? Then uh, what is the we can say what is the uh, after gaining one electron? What is the electronic configuration? 2, 8, 8. Now we will tell that the cells are same, that here 2 is 7 and here it is 2 8 8, but as there is in it will come in last outermost cell. This is M cell. It will come in last outermost cell. The one electron it will gain, it will come in last outermost cell. So what will happen that at negative charge repulse. So this due to electronic repulsion the size will increase. Okay, are you able to get it now the point? Okay, so next is that next is the size of isoelectronic species. Size of isoelectronic species means they have same number of electrons but depend on they don't have same number of protons. Like see Mg plus, Mg2 plus, then Na plus, then Mg2 plus, Na plus, Fe minus, O2 minus. They are gaining one electron, gaining two electrons. They are losing two electrons. They are gaining one electrons. Okay, are you able to get the point? See, first number of electrons are 12 total without losing. Then it will become 10, but the protons will become 12. Okay, now it is atomic number is 11, so electrons are 11. But it will if it will lose one electron, then it will become 10. Then total are 9. So means atomic number is 9. If it will gain, then it will become 10. Then the fourth one is O2 minus means it is 8 number, so it will gain, then it will become 10, but it is having same number of protons 8 9, sorry, same number of electrons, but it is they are having different number of protons and the size is also different. These are called isoelectronic species. Okay, this means this one we can say isoelectronic ion, but this all four uh, we can say here isoelectronic species instead of ions. Now the next character, means next property is metallic character. I will explain you in just this whiteboard. Now next we are saying that uh, next property is metallic character. What is the property of metals? First of all, metal property is to lose or gain. It is to lose. So lose means lose means forming cation. Okay, lose means forming cation. Okay, as it will form cation, we are able to know that we are able to know as it will form a cation. So what are able to know that, so the metallic character we have to, as we move down the group, the atomic size, we can say atomic size will increase, so the nuclear charge will decrease. Okay, but so what will happen, so it will not repel, plus it will not repel. Okay, means it will not repel means negative charge will not repel. So it is easy to gain, sorry, it is easy to lose one electron when the nuclear charge is less. Okay, but it is easy to lose one electron when the nuclear charge is less. Okay, I would understand my point. And across the period, if we say, so shells remain same. As the shells are remaining same, we are able to notice that nuclear charge will increase. Nuclear charge will nuclear charge will increase. As the nuclear charge will increase, then we are able to notice that the the size will as the nuclear charge will increase, then we are able to notice that it is very difficult to lose a electron. Okay, it is difficult to lose one electron, and it is difficult to lose one electron, then we are able to notice that lose one electron, so the metallic character across the period decreases. Okay, now next is uh, non-metallic character. You can check here that what I have said, it is correct, and it's obviously on. Next is non-metallic character. Non-metallic character means those elements which have a tendency to gain electrons. Orbits are we have tendency to gain electrons, means which have a tendency to gain electron, means that see, tendency to gain electron means that tendency to gain electrons. See, tendency to gain electrons are the properties of non-metals. Okay, so if as we go down the group, the metallic character increases. Okay, so the non-metal character will decrease, and as we grow across the period, the metallic character will decrease, so the non-metallic character will increase. It's the vice versa, and you have to check the property of nuclear charge only in this case. Okay, and this both property are vice versa of each other. Now if we check here, then we are able to know that non-metallic character. Then next is chemical reactivity. Chemical reactivity means that chemical reactivity means that the elements tendency to react each other. Okay, and if we check, then across the period, okay, across the period first it will decrease, and then it will increase, as okay, it will first increase, sorry, first decrease, and then it will increase, and down a group, then there are two, you have to say that, see, the most reactive, it is different for metals and non-metals. Okay, different from metals and non-metals. Check here, metals and non-metals. As see, the most reactive metal is at the bottom of group 1, means so francium. Francium we don't count, so it will be cesium. And most reactive non-metal is at the top of group 17, that is a fluorine. Okay, next we have to check the boiling cap graduation physical properties. Okay, now see, check here that boiling point of metals. Again, let me show you that boiling point of metal decreases. Why? Because see here, they are given also that melting point and boiling point, it decreases as we move down. because the nuclear charge will also decrease, no, means it will increase, but due to the last shell it will decrease. Okay, with respect to last cell it will decrease. And in non-metals it will obviously increase because it will first is gas, then liquid and solid. So as we see our as the last at the bottom of the group is solid, so we will need more energy. Okay, more energy to differentiate the molecules of solid. Okay, then we will need a higher energy. That's why the boiling point and the melting point will increase. Now, if we check about the across the period, then it will increase up to 14 groups. See, check here. It is still as it is increasing and then it is decreasing. Okay, and density, if we check, then density, see here density. If we check, then we are able to notice that then slight decrease may be noticed. First it will increase and then a slight decrease will be there, as you are able to see here. See, a slight decrease is maybe there, maybe not, it is there only, as you are seeing here that see, it will increase till 1.1.7, 2.7, 2.3. See, will increase in 13th group and then it will decrease 2.3, 1. And then it will slightly increase. Now if we check down a group, elements increases gradually. Yes, density of elements will increase gradually. As I have said that gas, liquid, solid in the upper that see gas, liquid, solid. So solid density will be more than gas. As I said you, yeah, as it will be more. Then the solid density will be more than gas. Okay, so it will increase down the group. Now here in-text questions you can do by your own or check the solutions on my channel. Okay, next, this this analyzing potential is a very important topic for your 10th first chapter, of your first chapter. You have to just recognize it and you have to work according it. But this topic I will, as it is a very important topic, we will start it from the